what I wanted to do was show you a difference between a transistor and a Mosfet. So here's a Mosfet. This is a P-channel Mosfet, and this is NP or PNP transistor. So that means that they are on by default, and then by adding a charge to them, they turn off. So this MOSFET is on this side, and this transistor is on this side. Now I chose the smaller variation of the transistor for this. I just wanted to show you that they look alike. The only difference is, the numbers on them, and certainly their application. Alright, so a transistor, the yellow one, this is the same circuit. Both of them are the exact same. So if I go to press this button, it instantly comes on. Okay, so this will interrupt it. It's normally on until I hit this button, and then it goes normally off. So that's pretty much what you get with a transistor, because it's running off of amperage. Okay, so if you want to affect it in some way based on a capacitor, for example, it's really hard to do that. And that's why they don't use those in motor controls, because of the amperage. Now, if you see a MOSFET, same circuit, I'll click the button. It has a lot of variation. So as voltage creeps back in, it gets brighter and brighter. So you have a lot more control over the same switch. So this is a slow burn switch, I call it. But those are some of the major differences. Is the fact that I can adjust the voltage on something to finite adjustments, and therefore speed or slow down a motor, where a transistor you couldn't do that. Alright, just to add one more note to the difference between a transistor that's running off amperage and this one's running off voltage, we have to think about the variation of voltage. For example, if I had like a 9-volt power supply that is 1 amp, okay, it is much easier to go 1 through 9 volts to affect this than it is to go to 0 to 1 amp to affect this. Okay, you have a lot of variance here that you have control over, where this one's a little bit more difficult to control. That you have to control this with the resistor, and this one you can control with many different capacitors, and you can also affect this one both ways, because you could also tie your resistor into the LED, for example, and then you could tie the capacitor into the gate. So there's so much more change that you can do here than that you can't do here because of that. This one almost acts as you can do both if you're really sneaky about it. Where this one, it's just amperage. Okay. So, alright, so I wanted to add that to it before I go on. Alright, sweet. So now that we have an understanding of a transistor is boring and a MOSFET is pretty sweet, it goes a little bit both the other way too. So a transistor is cheap and a MOSFET is a little bit more expensive, but still we're talking like pennies on the dollar compared to them. So now we're going to take and reverse engineer this design as an application, and then we're going to rebuild it onto a breadboard. Alright, so up until now, I have taught this class where it is just, I draw a schematic for you, and then we build that schematic. In this case, we're going to do the reverse operation of that, and then we're going to then rebuild it. Okay, because one thing is about reading schematics is kind of cool. Is, you know, like, you're always in the mode of reading schematics, but what if you went and built something and then you want to make a schematic? It's a little bit different mindset to take it from breadboard to schematic. It's easier to read a schematic and then take it to a breadboard, but to reverse it is a little bit more of a mindset. There's no doubt about it. So, for those who are watching this, I might include this as a YouTube video too, and still keep it within the class, but share it on YouTube also. So one of the things that we do have to catch up on the course is the capacitor. It goes like this, boom, 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 and then there's a positive. So just to know, that is how you draw a capacitor. Something I haven't covered in the course yet, but that's what they look like in the schematic. Alright, so when you're drawing a schematic from a breadboard, you still have to adhere to the idea that you want to know what things are going to go on within your circuit. So I always kind of use that mousetrap variation of schematic, so that I know exactly where the voltage is going, and I know where the amperage is going that way. So I would start with the Stoic Cyclops, and in this case I don't know where anything is yet, so I'm just going to draw one giant box. Okay. And then I'm going to draw the complex one first. So a P-channel Mosfet. I don't know why I chose that for this demonstration, but it is certainly a kind of a challenge to draw one of those, I'll tell you. It'll definitely get you kicked out at parties if you add this to a napkin. Okay, and then we have a gate, a source, and a drain. Okay, so very easy so far, right? Yeah. So now what we do is we know that on the Mosfet there's gate, drain, and source. Okay, those are the three pins in that order: gate, drain, source. So let's start hooking up things to the most complex thing first. In this case, this drain is hooked to the negative rail of the breadboard. Okay, so I'll just have this starting to head in that direction, just lightly. Alright, so the next thing is source, gate, drain, source. Source is hooked up to a resistor, and then it's hooked to the negative part of the LED. Okay, so we're going to do that. So first we start out with a resistor, boom, 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 just like that. And then the negative side of an LED starts out with the T. Looks like that. And then that's hooked to positive. Boom, 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 boom. Okay, and we draw these little things to let people know that it's shining light. Alright, sweet. So we got that. And now we have to deal with this switch. And the switch is kind of like complex in a way because we know that a switch has this area right here is all hooked together. So you're looking at a resistor, you're looking at the negative leg of a capacitor all being hooked into the gate even before the little thing is switched. Okay, and by clicking this, that's making this positive, okay, go in and then hit the gate. Therefore, turn the LED off. Alright, so we can start by saying, okay, well, we at least know the resistor's hooked up. Okay, we'll start in the back end and work our way forward. So the resistor's hooked up, and it's hooked up to negative. Okay, we'll start this in this direction. Boom. Reason I haven't ended this is because I really want to kind of like not go all the way out to this big box. I want it to look nice. Alright, then we know it's hooked to a switch too. Okay, the switch is a little bit less complex. So, and where does the switch go? It's going to the positive. So in this case, we got this, 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 this. Okay, cool. Alright. Now we also have the capacitor. Okay, the capacitor is hooked between the positive, okay, and the negative. It's already hooked up to the negative though. You see that? It's like hot. It's already attached to the negative. It's not active until you hit this button. Okay, so how do we demonstrate that? Well, in this case, since it's already hooked to negative, okay, so it's an awful long way down. I don't like that as a schematic, but that's alright. It's an awful long way away. So I might pretty this up in here in a minute. And then when it hits the switch, it's going to go positive. It's not bad. I don't like this abrupt turn that it's doing right here, but it's not bad. So now I'm going to seal it off and try to explain it. And it's a good thing to make it so that your schematics explain themselves. Somebody should look at it and say, oh, wow, I know what that's doing. So now you can cut off all this extra stuff. And generally, before we release a schematic, we always make sure that we have like an ink drawing or at least something that's built in like easy EDA to make it a lot easier for people to read it. Okay, so I got a positive charge. What's going to happen here is this is always on right now. Okay, so it's feeding the negative to the LED. The positive is already attached, so the negative is feeding the LED. Boom, boom, boom. It's always on, always on, always on. So what happens why it's doing that is because there's no charge. Okay, so it's hooked up to the negative right here. Okay, it's also hooked up to the capacitor at the negative. Now, when we introduce a charge to it, when it goes up here and we hit the switch is going to go down, the positive charge is going to go into the gate, and the gate is going to cause it to turn off. Okay? In the same instance, the capacitor it has a charge to it. Okay? So when we let off this still has a charge in it. And then it slowly dissipates that charge. So that is why the gate opens a lot slower. Okay, so boom, the gate shuts off, power shuts off. Alright, so that's how this circuit works. So it's a little bit different in what we did, because I always just kind of like draw a circuit for you, try to explain it as I'm drawing it, but this time it's already drawn or already made, so we had to reverse engineer that thought. Alright, so let's go on to now building it from the schematic. Alright, so here's my disassembled slow burn switch, and then we're going to rebuild it based upon the schematic. Just so you know that, like sometimes that when we're building a circuit, we're not always using a schematic. Later on, that you have the ability to like mix and match different switches together, and then you can composition things so differently with components. So you can draw with components just as you would draw with anything else, and you just know that, like let's say I had a transistor, a Mosfet, and another transistor, you could draw that out to make like a flip-flop, and that would be a more complex thing. So instead of a slow burn switch, but then you would have to translate it over to a schematic to let somebody else know what the heck it's doing. Alright, so not always looking at a thing. Alright, so we start out, again, just like anything else, we start out with the most complex thing first and hook that up. So we got, and this will help you out a little bit when I look at a Mosfet. Okay, so it's got this little thing. It's got 3 legs. Gate, drain, source. And this little thing right here is this little box. Okay. You sometimes also see it drawn like this. So that you know that you're looking at the top of it down, like that. Okay. Alright, so first off, with a MOSFET, you pick up what is it doing? Is it transmitting the positive or negative? In this case, it's giving the negative to the LED. So we attack the drain first. The drain is this second pin in. Alright, since I kind of just threw all my resistors in a pile, and these are the evil blue ones, what I usually do there is I just hook up my multimeter up just at the bottom of a circuit just so I can do this. So that is the 100K. Oh, and I should have said that this is 100K, and this is I think a 100K also. I just made it easy. No, 10K. So this is the 10K. Alright, sweet. It's the 100K. So the 100K, let's get back this. Boom. We're looking at 100K is hooked up to the G. Okay? But it was hooked up to the G in through the switch. That way it's saved on some breadboard. You don't have to do that, but in this case I'm going to hook it up to the switch. So the gate is going to be hooked up to the switch. This one right here. So I'm going this way first. And since the switch has a passive, and where's that going? Where's the resistor going? It's going into negative. Just like that. Alright, let's handle the LED next. And these are no in any order that it doesn't matter where you attack. I'm just attacking anywhere. So in this case, I have my source. That's the third pin on the Mosfet. And just so you have the view so far of it, so that you want to, in case I'm getting too fast for you, looks like that. Alright, so if you look, the LED's positive is hooked up straight to positive, and it's feeding the negative from the MOSFET. So the longer leg of the LED is hooked into the positive channel, and boom, it turns on. Okay. Why is it on? Well, because there's no charge yet to it. So the other leg of our switch, the one that transmits to this right here, is going to be hooked up to the positive. And you can see that here. Or roughly here, actually. Alright, nice. So now it just turns off, just like the transistor. So what we want to do is have it so it slow bleeds on. In this case, we have to hook the capacitor up between the positive, this, and the negative, this. So if you look at the capacitor, it has a negative stripe on it. This is a 47 UF capacitor. You can use any capacitor for it though, and the lower the number of this will make it so it's not so fat, or it just makes it faster. So if I used like a 3.3 UF, it would be certainly a lot faster. You wouldn't notice a slow burn. Alright, so there we go. Now, since it's got to now build up charge. So this thing is building up charge now. This capacitor is building up charge, and it has enough charge in it. So if I hit this button, turns the switch off, capacitor kicks in, capacitor is draining, and then the light turns on. And now this one can charge up again. Alright, so that is a slow burn MOSFET switch. Little piece of artwork. Hope you enjoyed.